Started. Again, welcome to everyone who's joined us today. I'm Samantha Link, and I'll be moderating today's webinar on rapid ultrasonic gridding for fixed equipment. As we go through the presentation, all attendees will be muted, but please be sure to send us questions through the Q&A feature located at the bottom of your Zoom screen. I'd like to go ahead and introduce our presenter today, Preston Canada. Preston is the Oil and Gas Industry Director at Gecko Robotics and has been in the oil and gas industry for the past 12 years. Preston has become a huge proponent in helping refineries understand robotic capabilities in the NDT space, as well as data utilization for rapid ultrasonic gridding inspections. Let's all welcome Preston.
Well, thank you, everybody. My name is Preston Canada, and I'm very grateful you guys are attending this webinar. Please feel free to ask questions through the chat, and Sam, our moderator, will get the questions to me, and we'll get rolling. What you'll learn in this presentation is we'll review some ultrasonic testing types for fixed equipment, introduction to rapid ultrasonic gridding, identify the technology platforms used in RUG, rapid ultrasonic gridding, and real-world examples of RUG at refineries. Now, it could be at a refinery, it could be at a midstream station, it could be upstream, or it could even be a pulp and paper facility. Anything with an integrity program, there are applications with RUG. So there's different types of UT signals I want to touch on when it's just to start at the basics of what RUG does. Very commonly used is D meters. D meters presents a digital display for the thickness, and you calibrate it on a step wedge, like you would other processes. But in this application with the D meter, you get the digital display of the 3-digit readout. It's very simple to use, but it also doesn't allow the operator to be able to cross-reference a signal. One step up in the process is an A-scan signal system like a DMS Go or a 38DL Plus. These units are commonly used and accepted everywhere because it allows the operator to review the signal when they're taking these readings. This allows the operator to compensate for coating thicknesses or digital display of the thickness that may not jive with the signal. They can look at it at real time. And one of the importances of that is when you're taking these data points, typically with these types of systems, you lose the ability to audit that signal at the time of inspection. So you take the word of that inspector at that time of inspection, they record it in the logbook or they record it in the systems log, and then they present it to you in a table later. Other systems that present it differently would be a B or a C-scan unit. And this is taking A-scan signals in a continuous basis typically, like you're scrubbing or painting an area. And it presents it in a way that's easier to understand from a visual representation. But they still are A-scan signals put together for a map. Typical UT types for fixed equipment. These are all contact methods. You'll take UT point readings. That's just a random sampling of points, or I shouldn't say random. Sometimes they are very calculated, but it is a sample representation. UT gridding by hand is a step up. This is still a contact process with a single transducer, but you're drawing a grid like in that left picture there with the elbow. And you're taking the readings in a fixed spacing, and you're taking the readings, and you can record them in that area and try and repeat the inspection to follow trends. Straight beam scrubbing is a more continuous type of testing where you're seeing more continuous of the signal changes and the thickness changes. Rapid ultrasonic gridding is the new technology we're going to talk about in this presentation. It's a combination of UT gridding and a little bit of the automated robotics side, kind of like AUT, but it's a mixture between the two. And then there's AUT, which is the highest resolution of all the tests. It's a continuous scrubbing system that's put on, typically it's put on an automatic arm that follows a process, very high definition. But everything here has its own limitations, and we want to talk about that. Rapid ultrasonic gridding, it's an NDE method, just like AUT is its own thing as well. It performs UT. By definition, you can look at the definition on inspectioneering. they're, by definition, it's multiple transducers, 4 to 100 plus transducers that run simultaneously, and they capture raw A scan data. They can present it in B scan or C scan models, and what it is it's a transducer, and they're or multiple transducers at a fixed distance apart, and as they're scanning across the y-axis with travel, it has X number of transducers on the x-axis, and it's taking a swipe, a path, kind of like mowing the lawn, and it's taking readings in a grid as it goes. So you get the advantages of gridding something out and taking those point readings, knowing where the readings are in a fixed grid, but you also get the advantage of a robot crawler that can go anywhere on magnetic or ferromagnetic surfaces, and it's giving you that fixed data much faster than traditional UT methods.
So Preston, there's a couple questions here. So what's the best application for RUG versus AUT and vice versa?
Okay, that's a commonly asked question. It's a good one. RUG is a system that has robotic capabilities that can travel, it can climb up equipment, it can be placed on a piping circuit and can do its work from the operator controlling it with a controller. AUT, you have to get more to the area. RUG systems can be anywhere from a 1/4 inch spacing on the transducers on that x-axis, and but it does have a gap in between. AUT is more continuous, so I would say if you had areas that you're really trying to map out fine pitting or some sort of fine defect, AUT is a better option. But AUT is cost is pretty high, and access, you have to get directly at it, and the speed of it is pretty slow. Well, RUG is a very fast system. The system can take millions of readings and cover large surface areas in single shifts. So anything that is not just a small, narrow, focused job with access that you're willing to do off scaffolding or something along those lines that costs money as well, you should really look at RUG. That'd be the better option for most inspection cases. They both get you a very high confidence score in RBI.
Great. And then with RUG, are you getting a 3-digit readout or analyzing signal data?
So we present the 3-digit readout, but we are capturing the raw A-scan signals, and we store those with the file. And all of our reporting and everything we have that we'll present to you will be on a portal. So it's a portal that you can access from your phone, from your laptop. We filter the data because we're taking millions and millions of readings a shift. So we filter the data and present it in a way that we're not trying to flood you with too much data, but we can retain those A-scan signals for every inspection. And your subject matter experts, your level 3s, could dive into the data, cross-reference what we have, and do their audits. So we retain all of that. You get the best of both worlds. So these are common fixed equipment assets that we inspect with RUG. We have piping circuits, overhead crew lines, flare lines, process lines, headers, atmosphere storage tanks, the shells of them, the roof, the floors, towers, crude towers, vertical pressure equipment, columns, pressure vessels, horizontal and vertical, bullet tanks. They're all great applications for RUG inspections. And this doesn't have to be downstream, like I said before. This could be in any program that you're running RBI or you have an integrity program.
Now, can robotic platforms for RUG inspect elbows?
So right now we're limited on what we can do with elbows. We can cross the elbow on the flat side in most cases, in most diameters, and most curves, to transition to the other side. And we can take some readings as we're doing that. But we can't get the outer radius and the inner radius right now. We're working on that solution with our newest platforms. But right now we cannot. And what we do is when access is available, we'll go up there, take the hand readings in those areas, try and follow a grid or whatever procedure you have in that process. and supplement those readings back into our final report. So it looks like the data is all meshed well together.
And then how do you navigate flanges and pipe supports?
So flanges and pipe supports are definite considerations when we're doing the inspection. What we typically do, and I'll use an overhead line for example. On an overhead line, a lot of times we'll work off a JLG man lift. We'll place the robot on a section and we'll run that whole section. Then we'll pick the robot off that section and move it to the next side of the flange or pipe support. The robots that we have, well, they're on this screen right here, they all have a limitation of a 1/2 inch 90-degree transition. So if the transition is about a 1/2 inch to 5/8 and it's at 90 degrees, that's our upper limit. So most flanges we can't get over, most pipe supports we cannot get over unless there's a clearing on the top of it. If we can drive around the bottom of the pipe support, then we should be able to transition to the next section. But sometimes it is more time effective just to move it and place it. But the advantage is you only are putting your workers in harm's way while you're lifting it up, putting it on the section of pipe, doing the inspection. They're back down, then they go back up, move it. So it's very, very much limiting exposure risks. These are 3 of our most commonly used workhorse UT robots right now for RUG. TOCA 3, that is a very adaptable robot that can be made for piping, flat surfaces. It's one of our older models, but we keep it around because it's very effective and very useful. We actually have a version of it that can go up to 260-degree piping temperatures, and that's pretty awesome. TOCA 4 was designed for more flatter surfaces. We increased the transducer count. That one's up to 32 transducers, and it's a great tool as well. TOCA GZ is the newest guy on the block. It's up to 128 transducers. In the configuration in this picture, it's 96. Each transducer is a 1/4 inch apart. And as you started getting into thicker and thicker materials, that gap between transducers starts getting really, really small. So you get a very, very tight grid of coverage when you're using that type of platform.
So speaking of grids, there's a question that came in that's asking what are future improvements? So if you ran a crisscross pattern, wouldn't you produce a finer grid? And would the software be able to recognize same parts of defects that is, say, in one direction as it came from a different direction? Perhaps landmarks laid out on the surface would help you do this?
That's a very educated question. There's some procedural reasons we're not trying that right now, and it has to do with effective localization of these defects and trying to put them in the right spots with our encoding systems. We are working on the idea of getting to that point where a random path of the robot will result in very accurate location in mapping on the result of the data. But right now we're running these things as much as we can in fixed lines and fixed procedures to try and help with coverage, localization. We do overlaps, and we do run extra coverages. We try and keep everything in a straight line.
And so does RUG adhere to the API 653 inspections?
So to that question, that's a kind of an involved question. API 653 will allow ultrasonic robots for floor scanning. I think that's what the question was asking or intended to touch on. API 653 says that you can use MFL, you could use ultrasonic testing methods, and then it lists out the defects that you need to test for on a tank floor to have a good integrity program. Well, there are defects listed on that list that an ultrasonic platform is way more effective than MFL. There are some defects on that list, like small pitting that maybe fall in between that grid, that maybe MFL is a little bit better of an option for. So there really isn't a better way to do it. There is a way that's been done for the last 30 years plus, and that's been MFL. But MFL does not get you accurate data points down to the thousandth of an inch like a UT scan. So the number one thing to find defect-wise when you're looking for your tank floor per API 653 is wall loss on the tank floor. Well, MFL is going to flag things when it starts hitting the threshold of 50% wall loss. It doesn't tell you anything about 30% wall loss or 20% wall loss, where a UT robot, this UT program, putting this very fine grid on it, will tell you the exact condition of that wall condition. So it's a great option. It's acceptable within the guidelines because they are guidelines and they allow you to do what you think's best for your program.
And then how clean does the base metal need to be in order to do the inspection?
So flaking paint would be an issue because ultrasonics could not get a good signal through the flaking paint. If you have well-bonded coatings that are reasonably of thickness, so when I say that, 50, 60 mils of coating thickness we can scan through. But the surfaces does need to be fairly clean. MFL clean is cleaner than what we need for tank floors, for example. The robot uses water for the couplant, and the water itself does help with cleaning off the surfaces if there's a little dirt, grime. Can't be standing dirt or anything like that. And it also helps with filling, that water helps fill in the pits on the surfaces or the texture of the surfaces. And we're able to get signals through areas that you really can't do very well with contact UT. It is pretty awesome advantage the way we've done this with the water column design on our transducers. Rug platforms have some inherent advantages because they're robotic platforms with magnetic wheels that can crawl. We can cause a reduction in scaffolding and rope access. Rope access is way safer than scaffolding, which scaffolding is one of the most dangerous things you can have. But rope access still is people on ropes hanging, and it still is true skilled operators that have to work at elevated heights. A robot doesn't have those concerns. The robot with magnetic wheels, they're permanent magnets. It's not going to fall. It's stuck on that surface, and nobody's at risk at elevation. The robots are a force multiplier in the sense that a two-man crew with the robot can cover large surface areas that normally would require more inspectors. And we know reducing people reduces risks, and especially with COVID. Non-confined space entry, our newest robot, that 96 transducer robot, we are now doing tank inspections, non-confined space entry. We'll drive that robot in on a ramp, do the inspection, and drive it right back out on a ramp.
So for a suspect roof inspection, how would your robot handle that? And what is the weight of the platform or machine?
Okay. We've actually been selected to help people with that particular problem because of our robot weighs 45 to 55 pounds. We can, depending on the configuration of the roof and how it's designed, we can set it on the roof from the outside off of JLG and drive it around from the edge of the roof. That way nobody gets on it until we can verify the floor is in a good enough condition to stand on. Or we could come up a spiral ladder and deploy off a ladder, inspect the area. And if the tank's a very large tank, at that point, we may just scan an area to make sure it's safe to stand on. But we never have to put anyone on the roof until we've done the safe inspection to see the condition of that roof. Worst case scenario, the robot falls through a very thin patch. And the 50-pound robot goes through, it's on a tether, we could pull it back out. So this is some examples of what the reporting looks like on Gecko's rug inspections. On the left is our 2D deliverable report. What it's moving through is a shell inspection that was done at the water line or the vapor line, and the robot was able to run on the whole shell and identify the areas that needed targeted repairs. On the right is our 3D model, and you can see as you start inspecting multiple pieces of equipment at your facility, the advantages of being able to look at something at just a glance to see its condition and where it's located. And you can visualize how you would have to set up repair and mitigation based on just a quick reference of a 3D model.
So with the volume of data collected, how do we audit signal accuracy?
Okay, so because we're collecting all the A scans, even if there's 20 million readings, we retain all those A scans, and we can bring you behind the scenes, your subject matter experts, and we can go through the A scans with you to show you. You can look at every signal if you wanted to. We've had some companies when they first adopted us send their level 3s in and review the process, make sure that everything looks good to them. We have no problem doing that. It's transparency that we like to show.
And then how do you set up subsequent inspections with these robots so that the inspection data lines up?
So we do like to start at the same spots and just help with consistency. So we'll start at the same flange on a piping circuit, or we'll start at the typically a manway or east, west, north position on a tank. So we'll start in the same positions, but the robots have encoders and the robots have systems that the robot knows where it is during the inspection. So that lining the data up is mostly done with the positional accuracy of the robot, but we use our procedures to help make sure that we're putting everything in the right spots to put the data team on the right path to not have to process through that. All of our data and reporting is done off-site in Pittsburgh by a data team that just specializes in going through this data. So the operators are verifying it while they're on site, that they're getting good signals. They're verifying that everything appears to be working in the sense that they're getting the good signals, the transducers are working. But the data analysis is done off-site because it's a lot of readings. We need a lot of computer power to do that. So one of the big advantages of RUG platforms is the speed. These are things that we can complete it in one shift. 250 to 350 feet of 12-inch overhead line, a 40-foot diameter tank floor, a 40-foot diameter sphere, and a horizontal bullet tank. Right now, we're not even saying a size on that because we haven't ran into one that we couldn't do in one shift. Very fast inspection. A lot of times we're compared against AUT. This is a particular job that we did that the client came back and gave us this information. We were out there for 4 days with 2 inspectors. AUT for the same inspection they did previous interval was 28 days and 4 inspectors. They said it was a 300% reduction in cost compared to AUT, just on the invoicing, not looking at all the other factors of cost as well, which were big advantages for RUG. And in these inspections, it was pretty much apples to apples with 7 million readings each. So why RUG on your fixed equipment? You have the speed advantages. You have the data volume and accuracy. You have the ease of access. You can access the software portal. You can download an Excel sheet. You can download a PDF report to keep in your files. But you have all this on access from a portal that you can deem whoever you want to have access to at your company. You can even give people temporary access. We've had clients that wanted to do targeted repairs, and they gave 3 or 4 contractors temporary access so they could look at it, bid it. Then their access got pulled when they no longer needed it, but they were able to very accurately look at the areas that need repair, and there was a lot less questions on job scope at that point. And you get a very high confidence score in RBI when you're looking at wall thinning type of damages. Specific case study here, butane sphere, we got almost 650,000 UT readings, 2 operators, 1 robot, 1 shift, 178 readings per square foot. Pretty amazing value inspection right there. The more traditional ways to do this would be hanging off ropes, which you have the challenge of the rope wanting to hang at the equator of this, and you got to pull yourself in to do the inspection underneath. You would never get that kind of data coverage unless you're doing some form of AUT, which would take a very long time. Or you're building scaffolding and you're doing AUT, or you're doing just point readings. So RUG offers an incredible value in inspection for spheres. This is a fractionator overhead line. The surface was 240 degrees. It was 300 linear feet, almost 500,000 A scans. 3 operators, 1 robot, 3 shifts, a 70% reduction in man hours and exposure on site. This was a great project. Line was left at 240 degrees while we were doing the inspection. Pretty awesome value as well. Sour water tank. We mobilized in 24 hours. This was an emergency job. We completed it in 1 shift. We almost got 300,000 readings on this one. Only 2 inspectors needed. Multiple section of internal corrosion was identified. Tank was permitted to operate for the next 2 years. That was the goal of this inspection. How do we extend this tank for another 2 years when we're going to take it down and decommission it anyway? Well, we were able to go in there, and because we provided such an incredibly high volume of data, and we gridded the tank with UT readings, they were able to make targeted repairs. They were able to spend $50,000 and get this tank back in service, and it's going to last another 2 years because of this. And it was a great success. So in conclusion, your A-scan data can be audited. You have extreme access advantages with magnetic wheels, climbing robot. You've got cost savings by eliminating scaffolding and rope access, not to count the cost savings you also get from just knowing the asset integrity and the plans you can make around that. You have the speed and safety of this robotic system. You're not putting people in nearly the harm's way as you would in more traditional methods. And you get high data density for asset management programs. I really thank you guys for joining us. And if you have any questions, please let me know.
All right, thanks, Preston. So let's jump into a Q&A. Just as a reminder, if you do have a question, please feel free to send them via the Q&A feature at the bottom of your Zoom screen, and then we can answer them live. So one question that's come in, Preston, is have these been used for inspections on below grade piping? And what is the smallest diameter pipe that one of these robots would be able to fit in?
Okay, so we have not used this below grade in the sense that it wasn't excavated. If it was excavated and it was a direct assessment, we could do that. But we are not running these robots on the inner dimensions of these piping circuits right now. We're doing all piping circuits OD. On OD, we can get down to 6 inches.
Great. And then somebody wants to know, what is the cost of doing something like this? What is the cost of RUG or using a RUG platform?
That's hard to answer because we do have different platforms and different, we tend to travel. So there's deployment costs. We would like to quote that out on a project to project basis. You'll pay more for a RUG inspection on the hourly basis and on the daily basis than when you do other inspections, but your real value is the speed and the surface area that gets covered with these type of systems.
Great. And then are the probes detachable? I think they're wondering to enable the robot to scan smaller diameter pipes.
So everything's OD on the inspection with piping, and we can move the transducers in on some of the robots, but we're down to 6 inch diameter piping, as small as we can go. And the least amount of transducers we have on our platform that I know of is 8.
Great. Okay, so how would you recommend when to select rug based on threat? Would you work with our corrosion engineers to understand size and spread of the damage? You mentioned small pitting, perhaps very localized damage. With full coverage, do you think you'll likely see some part of the damage and then perhaps bring in AUT to scan the particular area of concern?
Yes, I see that as a very good way to run the program. Rug is faster. Rug is less fine of inspection. So if you are looking and chasing smaller pitting areas and smaller corrosion patches, then it would make sense to do a flagging with rug that could be cover surface areas quickly and be cheaper in that sense per square foot, and then come in with a fine tooth comb of AUT. We are trying to get to the point where rug can do it all with smaller and smaller spacing on our transducers, but there's still a need for AUT, and I think they do work well together.
Great. So those are all the questions we have for today. So thanks for everyone for joining us. This was recorded, so we'll be sure to send you guys a recording as well. And if you have any further questions, please reach out to Preston directly.
All right. Thank you, everybody. Have a great day.
Thank you.